And you have so many.
Okay, is it wrong?
Hi, I'm Kevin Wang, and we developed the SOVC. I'm going to use this truck mount as an example to show what SOVC is, why it's different, why it is better than a spring and disc, and why it's different than a Kunkel valve. So, which by the way, I brought to the marketplace years ago as an inferior technology. So I brought it to market as an improvement over spring and discs, but it really stunk, so we invented SOVC, which is exactly what we wanted. So what's different about a truck mount than a vacuum cleaner is a vacuum cleaner uses fan blades to spin the air. And you can put your hand over it and it just creates resistance, and the air slips through those blades backwards. Just like me putting a piece of wood in front of a fan. I'm going to stop the air movement, but it's not going to burn up the fan or keep it from spinning. But blowers are different. Blowers are used on truck mounts because they demand that you move air. And so what they do is there's 2 to 3 chambers based on a dual lobe or triple lobe blower, and they take a chunk of air and they seal it, just like you put it in a mason jar. They grab a chunk of air, and the size of that chunk is the dimensions of your blower. So this has a really nice, very large blower. It is a 56 blower. And what that means is, if I were to measure that mason jar, it's 5 inches tall and it's 6 inches long. So a 33 blower is a 3-inch jar, 3 inches tall, 3 inches long. It grabs that much air. So 36 is twice as long of lobes, so twice as much airflow. And so it seals it and it pushes it to the other side. While it's doing that, it grabs another chunk of air and seals it. If you have a dual lobe blower, then it's grabbing 2 of these big chunks per rotation and sealing them. If you have a 3-lobe blower, then the diameter is 1/3 of the first number, not half, or not equal to. And so it grabs 3 small chunks of air per rotation, but they both grab almost exactly the same amount of air per rotation based on their size. So the longer the lobes, the bigger the bottle of air it's going to seal. The shorter the lobes, the shorter. The first number is the height of the lobes, so it's actually the gears in the back of the blower, and so that tells you how big the diameter of that bottle is. So it seals it, and so there's theoretically a tiny amount of slippage, but for all intents and purposes there's no slippage. So what happens is, if you were to run a blower and not have a spring and disc, and I put my hands over this, one of 6 things is going to immediately happen, because it's not a vacuum cleaner. It will collapse my waste tank. It will shear the shaft off my blower. It will shear the shaft off my motor. It will shred my belts, or it will tear a hole in my hand, or it will stall my engine. But one of those 6 things is going to happen like that. And you can't have that happen, because we all stick our hands over the hose, or you suck up a towel. So they all have to have a safety system. So that safety system is that you put a spring and a disc on a system. And the way they all work the same. There's some type of disc and there's a spring, just like this. I don't know if you can catch that in the picture. So, but this is a great example of every spring and disc. It's got holes that let the air go through. It's got a spring. As spring tension increases, it opens up, bypassing air. So when I close these off, this opens. If I close these off to half of the blower's capacity, this will open enough to let half of the airflow go through. So I'll pick on a more common blower because I have the numbers more memorized. I'll pick on a 36 blower. So you have 280 cubic feet per air that are going to suck through one of these ports on that blower. Now, at no load and at 72 degrees at atmosphere, at sea level, it's going to pump 280 cubic feet per minute through that port. Now, you guys experience something when you clean that as you add hose, it gets weaker. And then you put a wand on it, it gets a little weaker. Then you put that wand on the ground, it gets a lot weaker. You know, but your vacuum goes up. So people think that the vacuum number is the power. It's more like your potential power, but really what it is it's the resistance to moving the air. So while the air is moving freely, your vacuum meter should read 0. If your vacuum meter is reading 2, 3, 4, 5, you probably have a design flaw in your machine, or your waste tank filter's dirty. So as you add lengths of hose and you watch your vacuum needle going up, what you're seeing is the resistance to moving that 280 cubic feet per minute. And then when you put the wand on the ground, you'll watch it go up to, 10, 12 to 15, whatever. And now what it's saying is there's huge resistance to moving that air. It's getting harder to pull that air.
Right, okay.
So now your blower will move the same amount of air no matter what the resistance, because one of those 6 things is going to happen.
Okay.
That's why they're called positive displacement. You've sealed the air.
I remember you telling me about that.
Yep, it's been sealed and you're moving it to the other side. Once it's sealed, it's sealed. Nothing's going to happen to it. So, so every truck mount has a spring and disc, and they have a factory setting. A lot of carpet cleaners are like, oh, I want more vacuum, and on yours, you'd be tempted to turn this knob and turn it up higher. It's a really bad idea, because you move closer to one of those 6 horrible things happening. And you will get more vacuum at the wand because you've allowed a greater load on your machine. You've made it work harder. So you do get a little bit better extraction, a little drier carpets, a little more airflow, a little more cubic feet per minute at the wand, just a hair more. But you've increased the load on your machine tremendously. And you can damage it, break it, wear things out faster. So always stick at the factory setting levels. Like ProChems, it's 12, Hydromasters was 13, some truck mounts, old Century machines were 15, and they worked hard.
This one's at 18.
18 is super high number, so you probably have at least 3 belts or a direct drive.
Direct drive.
Yeah, and you have a really big motor to support that load. And 18 is real high, so it also means that your waste tank must have a lot of internal bracing, or this bad boy would collapse.
That's right.
Yep.
It's all stainless steel.
Yep. And so, but you would be inclined to think, oh, I got 18, that's a lot of power. My machine's really strong. Well, what it means is, no, it means I can pull hard, and I'll show you that I'm pulling hard, but it doesn't mean I'm moving a lot of air.
Okay.
So, for example, to give you some extremes, if I put my hands over this ports at full RPM, you're going to read 18, right?
Yeah.
Well, how much air is moving through my hands? 0. So that gauge isn't telling you the cubic feet per minute that's going to the wand. It's telling you how hard the machine is working to try to pull it. Now, if I had an airflow meter and put it at my hands and sealed it, it would still read 0. But if I had an airflow meter in here and you had a 36 blower, you would read 280. You'd be 280 CFM going through there because it ain't going through here. So when we invented the first fully computerized truck mount, we put 27 sensors on it, and we got telemetry of 40,000 times a second of what's going on with that data. Well, in the units that we developed, we had a CFM meter in it, and it measured the CFM going into the blower, as well as where the shaft position of the blower was, and the pump and the motor. So we knew all the shaft RPMs as well as positions, and our telemetry showed us that we were losing like 90% of our cubic feet per minute. And we're like, whoa, what's happening? So we thought, oh, it must be bad vacuum hose cuffs. So we glued them all shut, and it was still almost the same number. So then we thought, oh, it's the connection. So we duct taped them. Then we thought, oh, it's the waste tank gasket. So we sealed that and then ran duct tape around it really, really well. It was the same number. So we had to sit down and go, where is 80% of our power going? What's happening here? We had a high vacuum reading. We were reading like 18 inches on ours, but we're like, but there's no CFM. Where's it going? Like, we're getting like 20 CFM at the wand when we ran 325 feet of hose, and we're like, where's the other 260 go? And so we sat down and we realized through the spring and disc.
That's where you're losing it.
So
the 80%.
Yeah. So we were losing 220 out of 280 cubic feet per minute at our spring and disc. And so we realized, oh yeah, this is not a control system. It's more like a circuit breaker. It's
safety.
So it's a safety, but it's a stupid safety because circuit breakers are on or off.
Okay.
What this is it's a spring, and a spring is like a teeter-totter. A teeter-totter says the more weight you put on me, the more I'm going to open. So as I push on this a little bit, it opens a little. I push harder, it opens more. I push harder, still, it opens all the way. So what happens is, if you were to watch this, and I fired up your machine, this would be closed. And I went like this, it'd probably still be closed because it's easy to suck a large amount of air through one port. But if I covered this up, say, 75%, or let's say half, this is going to open up enough that half of the CFM will go through here and half through here. Now it's 75% load, 75% will go through here and 25% to my tool. At 80% load, 80% goes here, 20% goes here. At 90% load, 90 goes here, 10 goes here. At 100% load, 100% goes through. So it's a complete linear bypass.
Gotcha.
It's graft. It's a straight line. So the problem with that is when even the simplest job with the shortest amount of hose, I might read 10 inches on my machine, right? Okay. And what that means is that this is going to open maybe 60-70% of the CFM. Now this doesn't have to open far to let that happen. So a lot of people are like, oh, it's barely open. Yeah, but if you put a meter on it, you're going to see the numbers. That's why we built machines for 15 years and never knew this until we looked at telemetry data from a computer controlled system. And when we saw that data, we were like, oh crap. What we wanted to do though is we want all the CFM to go to the wand. I don't want to lose 80 or 90% of the cubic feet per minute from my wand slot, because what extracts water is not CFM and it's not vacuum. People think it's vacuum. It's not. I can put a drop of water on my hand, put a straw over it, and suck on it 25 inches of mercury, but that drop of water is not going to move. It will stick there because it's sealed. And I can take that straw off and put my hand in front of a fan that's 10,000 cubic feet per minute, and that drop of water will stay in my hand. Now it will slowly evaporate, but will stay in my hand. So what actually extracts water is what we've coined a phrase here called slot velocity. Okay. People don't really understand it. It's a combination of both CFM and vacuum. So what happens is when you break open an opening close to that water, the external air pressure is at 14.7 psi at sea level. That's what pressure is on our body. Yeah. If I remove all of that from inside my wand, I will have 30 inches of vacuum, and I will pull all of the air from outside will push into my wand with great force. And the speed at which it does it is the cubic feet per minute. Okay. So how fast it's creating friction against those water droplets is the CFM, and how hard it could pull them or push from behind is my inches of mercury.
Kind of like the glides, right? With the little pinholes and how fast you can recover water with the
that's a whole another discussion. I'll keep it off of this.
Okay, go ahead. Keep going.
So what really extracts water and dries carpet is a high slot velocity. Gotcha. The way you create high slot velocity is tremendous CFM with great pressure. Now, you can get 18 inches on here, right, by having a long hose on here and putting a wand down and having a big blower. You get the pressure, but you've gotten rid of 80, 90, 95% of your CFM. So you think, wow, I'm at 18 inches of vacuum. That's great. I want to know, what is your CFM out there? Because the one equation without both of them working is worthless. It's kind of like pressure washers know that you need gallons per minute and PSI. Yeah. You can buy a shitty pressure washer at 3,000 PSI, but it's 1 gallon a minute and it won't clean anything. So you need large gallons per minute and high pressure. You need both. Well, in our marketplace, for similar reasons, you need both. Okay. So I started looking for a different way of doing this. And so I'm a mechanical engineer and a chemist, and we also have other people that were helping us, and a lot of other engineers that I talked with, trying to solve this problem. And so we were looking for a way of changing it from a straight line to a line where all of the airflow goes to the wand, but then to protect you and the machine, to protect against those 6 tragic errors, which you must manage. We wanted it to then bypass. So I found Kunkel valves. I was looking for something that acted like a circuit breaker, not a spring. Okay. I didn't want a linear release system. I wanted a digital release system. So we found Kunkel valves, and I found them. They were made by a company called Tyco, and they used to use them in the 1800s to keep boilers from exploding. So when a boiler built up so much pressure, it was getting ready to explode. Instead of blowing up a whole neighborhood, like you could look up boiler explosions, they killed thousands of people in the 1800s. Train boilers would blow up, factory blowers, they take out city blocks. They blow up like dynamite, huge bombs. And some of them took out city blocks. And so Tyco invented the Kunkel valve. The Kunkel valve ran backwards, will manage vacuum. And it gives you a kind of a digital release. So we started using those, but we immediately found out that there's a bunch of problems. One is a Kunkel valve works like a circuit breaker until it gets to about half load, and then it's still got a linear release. It still weeps, and then it pops open. So the curve on a Kunkel valve is completely closed, and then it works like a spring and disc, and then it pops open. So if I showed it in vacuum this way, because you full vacuum, then it starts dropping right at the end, and then it dumps. So I didn't like this dropping. The other thing that's really bad about a Kunkel valve is where it resets. So you have to drop about 4 inches of mercury before it resets. So let's say you're at 10, you're going to have to drop down to 6 before it resets. So you could be wanding, thinking you're cleaning. You've lost a huge amount of your power because the circuit breaker's popped. So, and the last part, from like 75% to 90% load, it works like a spring and disc. It's getting ready to pop, but it hasn't quite popped, and it leaks really bad. And so where you need the power the most, it's not there for you. It's starting to work like this. So a Kunkel valve was a great improvement. It gave us a lot of low-end power and CFM, but where we needed it the most, it fails completely. And then it has this really bad effect of having this high, it's called hysteresis. It's a high range that you have to drop below before it resets. And the reason for that is it's built on a spring and disc technology. If you take a piece of metal and you bow it, you can put weight on top, and it'll hold a lot of weight until it's too much, and it pops over to the other side. So you're too young, but I'm older. We used to get Cracker Jack boxes, and they'd have this little clicker in them, and you could pinch it, and it would go click, and you'd let go, and it'd go click, and you could make these. They used them in World War II to find each other in the bushes. And anyway, that was just a bent piece of metal. Kunkel valve has a bent piece of metal in it with the valve. This stem is attached to that bent piece of metal. So I don't know if you can see up there. So that piece of metal is bent to the metal. So you put a vacuum load and it stays put, but then all of a sudden when it pops, it pops it all the way open. You dump everything. And then it has to drop all the way back down 4 inches of mercury before it resets. So we're like, you know.
So there was probably a time frame that it went down.
It goes down, and the problem is most cleaners don't even know it. One time I was playing with a buddy of mine. I saw him cleaning a bank, and he was behind there wanding, and says he was a really good customer and a good friend. So I went out and I turned his heater off, thinking he'd catch that all of a sudden his wand's cold. And I went back there and he's still cleaning. I went further over, I turned off his chemicals, thinking he'd seen no foam, and go back there, he's still cleaning. So when I turned off his pump and I walked back over to see him, he's still wanding, no water, going like this. So I just unplugged his vacuum hose. And I think he's going to run out to meet me, like he's going to know his machine's on fire or something, and I would tease him. Well, I go back there, he's still wanding. He's in there wanding. No water. He was in the zone. He had cleaned like 4 or 5 teller booths. The point of that, I just brought that up, is because when you're cleaning, you really don't know. You know, you don't have gauges on your wand telling you everything that's going on, and you don't have a CFM meter. So what we did is we invented SOVC. So
can you what does it stand for?
Solenoid operated valve control. So we wanted something that would pop like a circuit breaker, and it had to be able to monitor the CFM and the vacuum levels and be able to control them independently, which this can't. This brings both of them down. The more you put a spring load on it, the lower your vacuum and the lower your CFM.
So it has a microprocessor, right?
It has a processing ability to look at what's going on your vacuum and your CFM, and then make a decision to answer this question: when do I need to protect this machine?
When it's at a high.
So when you order an SOVC, you have to tell us what machine it's for, and then we have a table of all the different factory set points. So we do not increase the load on a machine. Now, units that are out of warranty and people for weird reasons want to push the envelope, then we tell them the dangers, and we say, sure, but you bear the weight of that decision. So it's like against medical advice. But we'll do it for them. And I have a lot of guys that have done that. Maybe 150 guys have done that. And certain truck mounts are built rugged enough that you can push them more.
Kevin, grab the SOVC.
So this is an older one, and we've changed our processor since then. But basically, what they do is this goes in place of this, and it has a screen to keep dirt out of the valve system. And what this is going to do is this one is set for 17. So this one is going to send 100% of the airflow out. So let me give you an example where this would really shine. Let's say I'm going to run 400 feet of hose to do an apartment, right?
Okay.
And most people wouldn't even try.
Yeah.
But because their machine would be dead in the water, because it's such a high load, you're up here at like 95%. At that point, a portable's stronger.
Yeah.
Right? So, but, you know, so 95% goes through here, you know, 5% through there. Well, what SOVC does different is it goes, wait a minute, we're not above the 17. So we're going to tell the blower, you have to send 100% of the airflow out there. You see, the blower doesn't know that the air's moving here or here. It can't tell the difference. It doesn't know.
Okay.
It's the spring that made that decision. I can tell the blower to send 100% through here by plugging this completely, but then I can't manage those things, those 6 things that must be managed.
Right.
So this manages them. And unlike a Kunkel valve, it doesn't lose its power in the last 75 or 25%. When it gets to 75%, it doesn't lose, you know, its CFM, and it doesn't pop, and it doesn't have that hysteresis issue.
So the load stays consistent.
It sends 100% of the airflow to your wand, and then it can think for you. So let's say, I'll give you some scenarios. Let's say I'm doing 1,000-foot line of hose. Well, an SOVC can do that. Even with a shitty, I shouldn't say shitty, even with a poor quality little truck mount.
Right.
So that's why we do a contest. We pay $10,000 to anybody that can outperform our smallest truck mount. Steam Action's been in that.
Yeah.
They didn't win.
No.
Against our smallest truck mount.
I think even a Vortex too, right back in the days.
Yep, with a 16 horsepower and a 36 blower, couldn't outproduce. ProChem brought their big stuff, Hydromaster the big stuff, couldn't beat our weakest unit in that in CFM or in vacuum because of it. So let's go back to the 1,000-foot scenario. It'll send 100 feet, and you can run 1,000 feet. Now that may bring me. It may take more than. Let's say your machine is 18, but let's pick on a number that's more average. Let's say it's a ProChem and it's 13 or 12. 12 is ProChem. So I can't pull 280 CFM through a 2-inch hose 1,000 feet with less energy than 15 inches.
Correct.
So what this will do at that point is it makes a decision on how much can you pull, and it releases measured amounts to bypass your hose and sends the rest. So it's monitoring it, going, well, what can you handle out there? Can you handle 200? If you can't handle 280, can you handle 250? And if the answer is yes, 250 goes to the tool, and the balance is vented. And what you'll hear this do is you'll hear a little psst. And what it just did is it just dosed out a measurement of air to keep you below that 12 inches of
That's awesome.
Right. So if you plug your hose out there at the end completely, it'll open all the way and it'll just go psst and keep you below the set point of your machine, protecting it. So it's still instant.
Yeah.
It opens in 1/10,000th of a second. So plenty of time to protect those 6 issues.
Could it also protect the blower for its life?
Well, it protects it in that you're not going to be overloading it, and it protects it in just good management of the set points. You know, sometimes these can get stuck a little bit. Sometimes they don't operate smooth. Sometimes
give you more life of the blower.
It can a little bit. I don't advertise that for that, and I'll tell you why is because so many people do so many different things in the field, and people MacGyver their machines, and we can't monitor employees making bad decisions. But what it can tell you is it provides perfect protection, and when we do that, we have to take on the warranty responsibility. That's one of the reasons why we use tamper-evident stuff, and we built that for our wet environment. So, you know, they're designed to be able to deal with you guys beating wands against them and throwing chemical splash on them and all that kind of stuff, because that's what carpet cleaner vans, they're always full of that. Right. I mean, you have a really nice van and it's really clean, but this is not normal. Normal is pigsty, and step in and my foot goes through the floor. You know,
like sewage,
which has happened 24 times in my career.
Thank you, Kevin.
Yeah, so that's what SOVC does. We do have some interesting warranties on it. One is we have a money-back guarantee that it will cut your dry times at least in half. Now we claim in half, but it's really going to be 4 times faster. So if I cleaned a carpet that took 4 hours to dry, and you put SOVC on it, it's going to take 1 hour to dry. We'll give a money-back guarantee on the technology if it's not dry in 2 hours. Yeah, so we put our money where our mouth is. We also have a 7-year warranty on it. So we put a 7-year unconditional warranty on SOVCs. And then if people really want to haggle us, we have this $1,000 thing. We will pay somebody, we'll give them their money back plus an extra $1,000 if it doesn't do exactly what I'm about to say. If it doesn't, at minimum, double the CFM at your watt. At minimum. And what it really does is 4 times. But the only reason we only guarantee double, it's not because it won't do 4 times. It's because carpet cleaners can't judge their CFM. They don't have a CFM meter out there. Right. And so I don't want a guy coming up to me and going, I want the $1,000 because I believe it was 3 3/4 times as strong, but it wasn't 4. I believe it was 370% increase, but it was not 400%. So I want the $1,000. I don't want that argument.
Right.
So we just set it up. We do have CFM meters, but it takes me an hour and a half to set them up. It's a big deal.
Is it really?
Yeah. And so, you know, it's not easily measured. It's why it's in some ways the most misunderstood portion of truck mounts, because you have gauges for everything else, but it's really hard to measure CFM, especially through what's going to a wand.
So on this particular unit, what would you recommend for the setup? For
your blower size, you need a large SOVC.
Really?
Yep. So the one I just showed you is for our smallest ones. It works up to a 36 blower.
Okay.
So a 45 and a 47 take our mid. Anything over a 47 in size, then it takes the larger. Now some truck mounts are pulling down on the ratio, and so you might have a 47 blower, but it really moves the air of a 33 or a 36. Examples of that are most power takeoff units where they use the engine. So they'll pulley that down, and for advertising they'll have huge blowers, but they're spinning at 500 RPM, not 1800 or 1750 that they can. So they spin them like half the RPM, so they move half the air. Remember, you're sealing that air, and it's based on how many rotations per minute. You're making 2 or 3 jars of air that you're sealing. So if you do it half as fast, you're moving half the air.
Half the air. I get it. That was a good way of putting it. You know, because I didn't really understand how it worked, the technology. I saw the your literature, but I'm glad I had a chance to talk to you about it. And you give us a whole history on how you came up with the SOVC valve, because the Conco valve was a big upgrade. You know, at the times, what was it, in the 90s and going into 80s and 90s, right?
90s, but but not a good technology. You know, we just reached into the past back to 1840, 1850 is when those were invented. Wow. So. Yeah, and then just ran them backwards to get them to manage vacuum instead of pressure. There's a lot of problems with chemical valves. They have to modify them to make them work on a carpet cleaner. Tyco, who makes them, says don't put them on these machines.
They do, huh?
Yeah, so the manufacturer of the valve, not the people that sell them to you, but the people that make them, say don't put them on a carpet cleaning machine. And if you ask them why, they'll say because they're only designed to pop off once. They're a safety system. They're designed to prevent an explosion. So we guarantee them, we warranty them for the first time they ever pop off. Not 500 times per job.
Right.
And then they're not meant for the high moist environment. So
they get rusted and they get stuck.
They can get stuck. They can build up chemical residue. It's just, it's not designed for it. It's designed for blower or boilers. Not.
Do you have one today to install, Kevin?
We can do that. We can make that happen. To answer your question about blower life.
Yes.
So here's where we won't warranty what we warranted. Our guarantee doesn't apply. There's some cool ways to use SOVC. If you're going to get 4 times the airflow, then you could run your machine at half throttle and still have twice the power you have today.
Interesting.
Now, when you do that, now your blower is going to last longer, and your pump, and your motor, and everything else.
The friction, the wear and tear,
all that stuff.
You're saving.
Yeah. Then, if you're going to do a flood job at night, and you got to work around neighbors or something, half the RPM, way less noise. Yeah. And you can actually go to 75% less RPM and still clean the same as you do before SOVC. So now, if you're doing that, then we can't say it's going to be 4 times because you've changed the scenario. It's no longer full throttle like it was before. You're running it idle and to do your cleaning. So, but if you run it same RPM, you're going to get 4 times the airflow in general, and absolute minimum of double.
This thing has
and a bigger hose doesn't do that.
It doesn't. That was the other one. Remember, I told you
I could put a hose this big. A lot of people are like, "Oh, let's run 2.5 inch to the door. Let's do this." Okay, you can get some marginal increases because you're making it easier to pull the whole system to pull air. So when you make it easier, the vacuum level goes down and this closes more. So what happens is it's not the 2.5-inch hose that's getting you more CFM. It's that you're reducing the overall load. So this closes more, so more CFM goes through. So you do get more CFM,
Right.
but not because of the hose. You got it because you made it easier to move the air.
Got it.
Now, I could make a hose the diameter of your van, and this is still going to function the same way. I plug that whole hose up, this is opening 100%.
That's right.
I plug up, I create a load that's equal to 50% load. This is going to let 50% through here, 50% through my 20-foot hose. If I put an 80% load on that hose, 80% is going through here, 20% through that hose. So it doesn't matter what the diameter is. You know, I've always wanted to play this, and I haven't done it yet, but I've always wanted to take 1,000 feet of 1.5-inch hose and then hook up our CFM meters at the end of that and see what that does. Because in theory, as long as I was willing to probably go to about 18, I could probably get the same CFM out of an 1.5-inch hose as I do a 2. At the end of, certainly I could do it at the end of 200 feet. I know that. Just off my gut, I know you can do that, but I haven't tested it. So something to be.
That would be great for a YouTube video, you know, and have
Something
it,
like that.
you know, something that we can study it and see the results, you know, as the cleaning world, you know, everybody's interested in this. So if you're interested, you know, let me know. I have Mr. Kevin Wang from Power Plus. He's gave us some knowledge. He gave us some wisdom on how, you know, airflow and how cleaning and drying is so important with the release valve that's connected to the waste tank. If you're interested in this SOVC valve, you can contact me, DM me. I'll have them available for you. All right. This is Mr. Z. Talk to you later.
Oh, one thing can I add?
Yes.
Okay, if I'm cleaning a house, if you're following your ICRC cleaning pipe, and you're spraying hot soapy water and sucking it out, the goal of those things is to make mud. You basically got mud soup in a carpet or a fabric or tile and grout job or whatever. The more of it you suck out, it's not clean water you're pulling out, it's dirty water. So the more of it you pull out, the cleaner you've left that floor. So for carpets and fabrics, they're going to feel softer, and also it reduces the tendency to clean your shoes. So there's going to be less soap residue, and they're cleaner. So it's not just that they dry twice as fast, they're way cleaner. So, and deeper down into the fiber. So
very nice.
Something to think about.